Okay, hello. In this video, we're going to be solving question number 1 from test number 1, remediation. All right, so first, just going to read it. Avi the puppy runs at a constant speed of 4.85 meters per second toward a stationary remote control toy car. When Avi is at a distance of 32 meters from it, the toy car begins accelerating away at a uniform rate of 0.165 meters per second squared. If both Avi and the toy car continue moving as described in the same direction for a long period of time, Avi will have 2 attempts to catch the toy car. Due to her inexperience, Avi's first attempt at biting the toy car is a miss. What is the distance traveled by the toy car from the time Avi catches up with it the first time and when Avi catches up with it the second time? That's part A. Part B is, below a certain minimum speed, Avi would never catch the toy car. What would Avi's minimum constant speed need to be to have exactly 1 attempt to catch it? Once again, the toy car will accelerate from rest when Avi is 32 meters away. Okay, so before we go into acceleration, velocity, and what that all means, let's draw a rough picture. So we have Avi, which I'll resemble with A, right? She's going at a speed of 4.85. Now, I'm going to define the direction of speed. Positive is to the right. So that'll give this direction, because it's positive, meaning it'll go to the right. And this meaning we can call that a velocity now. So Avi is going that way into the toy car, and there's 32 meters between them, right? We know that the toy car is accelerating at a uniform rate of 1.65 meters per second squared. I'm going to explain more in depth what that means in a second, but for now, just think about it as speeding up. So it's speeding up this way. Eventually, they will meet, and eventually they will meet again. Those 2 points are where they will meet, and that's 32 meters. Okay, so first let's define velocity and acceleration. So velocity. Velocity can be written as delta x over delta t. What does that mean? A delta basically means change in. So change in x over change in t. X is position, t is time. So this velocity is equal to change in position over change in time. Right? So let's say my change in position, let's say I ran 5 meters in 1 second. My velocity is 5 meters per second, right? Because I went 5 meters in 1 second, right? Make sense? Yeah. For Avi here, it's 4.85 meters per second, right? Acceleration, on the other hand, is equal to delta v over delta t. So what that means is, let's say I'm stopped, and in 2 seconds, I reach a speed of 4 meters per second, right? So I go from 0 meters per second to 4 meters per second in 2 seconds. My acceleration would be 2 meters per second squared, because that's how much I'm increasing each time, right? And from these definitions here, let's get a formula that can give us an equation. Let's get an equation that we can use to solve this question. So first, we're going to multiply this delta t on both sides. So this will give us a delta t equals delta v. Right? Cancels on this side, goes on that side. Now, let's find a way to rewrite this delta. So another way delta can be written is final minus initial, right? Because it means change in, right? So let's say I have $5, that's my initial, and I find 5 more dollars, so I have $10, that's my final, right? My final is 10, 10 minus my initial, 5, 10 minus 5, my change is 5, right? Final minus initial, that's how you can rewrite delta, right? If your initial is 0, something minus 0 is that same something, right? So for time here, our time initial is 0. We're showing at 0 seconds, because that's when they're 32 meters away, at 0 seconds, right? We know that this is just t, right? Delta t is equal to t if t initial is 0, which it is in this situation. So we can rewrite that as at is equal to velocity final minus velocity initial. Right. Now with this, all we have to do is just add velocity initial to each side to isolate this velocity final here. So we get VI, a little arrow there, VI plus AT equals velocity final. All right, and that is our first formula that we are going to use and plug it into another thing, which we're about to find right now. Okay, so let's find that second thing. What is that second thing? In order to find that second thing, let's remember how to get an average. An average is the sum of things, sum over the number of groups. So, for example, if I have 5 apples and someone else has 15 apples, sum of our apples is 20 apples. Divided by the 2 of us, average is 10 apples per person, right? So we can do that here with velocity, right? Right? So we can plug that in. We have velocity initial plus velocity final over 2 equals v, right? Because our initial velocity minus our final velocity, or plus our final velocity over 2 will give us our average, which is our velocity, right? And we know that that is equal to this over here, delta x over, remember we figured out delta t was just t, so delta x over t. Okay, now let's rewrite this velocity final by plugging in this formula here, right? So in order to do that, we can just do vi plus vi plus at over 2, right? Just plugging in this value right here for that vf, because it's vf, right? Now we can simplify this by turning this into 2vi plus at over 2, right? These 2's will cancel for the vi, and they will still apply to the at, or it will still apply to the at will still be over 2, so this will be vi, draw a little arrow, vi plus at over 2, same equation as here, so it's still equal to delta x over t. All right, make things even easier, I'm going to rewrite this over 2 as times 1/2, because dividing by 2 is the same thing as multiplying by 1/2, right? So this is vi plus 1/2 at. That is equal to delta x over t. We multiply both sides by t, gets rid of this t on the bottom, and it multiplies it over here on this side, and that will give us our displacement formula, which means delta x is equal to initial velocity times time plus 1/2 acceleration times time squared. And this formula is what we're going to use at the end to get our final answer, right? Because that's what we're asking for. Distance traveled, aka change in distance, aka displacement, right? Okay, now what we have to do is we have to edit this formula just a little bit, right? Let's turn it into a position formula, right? Because we don't want to, we have to know when they are at the same position, right? Not when they have not when they have moved in the same amount, but when they are at the same place. So for our v, let's write our v's formula first. We know our v starts at the position 0, right? She's all the way back here. This is 0, right? So if I run 20 meters away from point 0, I'm at the 20 meter mark, right? My change is 20 and my position is 20. So that means my delta x is equal to my x. And that's equal to vit plus 1/2 at squared. For the car, we know that there's 32. The car starts at 32 meters, right? So if I start a race, or if I just start running at the 32 meter mark and I run 20 meters, my displacement is 20 meters still, but my position would be 52 meters, right? So the car is just delta x plus 32. So this formula plus 32. So for the car, x is equal to VI t plus 1/2 AT squared plus 32. Right? Yes. Okay. So now let's define our variables in the problem. Let's get our velocity and our acceleration for both a v and the car. Right? So let's start with our velocity. So the velocity of a v, I'm going to write that as VA. The initial velocity of a v, that's fine. VIA equals, what does it say? 4.85 meters per second. Right? And the acceleration, which I'll write as I'm going to do a little more space. AA, we know is 0. Why? Because it is a constant speed, meaning not speeding down, not slowing up, not speeding up, not slowing down. Speed is constant the whole time, so it is not accelerating, not speeding up, not slowing down. Acceleration is 0. We know if the speed is not changing, there is no change in speed. So that means velocity initial of v will be the same as the velocity at any point. So we know that the initial is just equal to the velocity anywhere, right? So I'm just going to call that VA. Now, for the toy car, the car, what's the initial velocity? We'll call that VC, okay? Velocity for car. That's equal to 0, right? Because it is stationary at the start. So we know this is 0. What's acceleration of the car equal to? 0.165 meters per second squared. Okay, now that we have these written down, we can do some things with these formulas up here, right? So if we know V's acceleration is 0, we know that this part of the problem, the formula will be 0 because everything is multiplied by A. So we can just ignore that part. That part's not there anymore. It's just plus 0, which will be 0. Or it will be just this because adding 0 does nothing. For the car has no initial velocity, right? So we can ignore this part of the formula, right? So it's just this that matters to us here. Now, what do we want to find? We want to find when the x of a v, right? I'm going to make this a little smaller, x of a v, because that's this here. I'm going to rewrite that, xa, xc. The x of a v equals the x of the car. That's when they're at the same place, right? Now, what we're going to do with this is we want them equal to each other. So we are going to set these two equations equal to each other, right? So in order to do that, we just simply put it in. xa is equal to VIT, not VIT, VAT, sorry. The velocity of v times time, right? Because this is velocity of v right there, times time. And then that is equal to our other equation, which is 1/2 the acceleration of the car times time squared plus that 32. Okay, so what we have to do now is let's get rid of this 1/2 because it's going to make things a lot harder later down the line. So it's better to get rid of it now. So let's multiply the entire thing by 2. Right? Okay. So what that's going to do for us is that's going to make it's going to make this 2 velocity of v times time. That's going to be equal to acceleration of the car times time squared plus 64. Right? Right. Now, what we're going to do is we're going to subtract this 2VAT from both sides. So that's going to give us ACT squared plus 64 minus 2 velocity of v times time. Now, we can rewrite this, just change the order using the commutative property. Acceleration of car times time squared minus 2 velocity of v times time plus 64, right? This is true, and that's equal to 0 since we subtracted it from both sides. Now, what this does for us is creates a quadratic, right? And how do we solve a quadratic? Well, we can't factor this, so let's use the quadratic formula here, right? So quadratic formula we know to be negative b plus or minus square root of b squared minus 4ac over 2a. So obviously, we don't have an a here, we don't have a b, we don't have a c. So let's figure out what they are. A normal quadratic is written as ax squared plus bx plus c, right? And in our case, our x is our t, right? It's just the unknown variable. It doesn't necessarily have to be x. In our case, it's t, right? So let's figure out what that is. Times x. The thing times x squared, our a in this case, is going to be equal to this value, ac. Right? Acceleration of the car. Our b going to be equal to this negative 2va. And our c is equal to this 64. Right? What we do now is we just plug these numbers into this formula here and put them into a calculator, and what we get out is two values, right? We get two values because of this plus and minus right here. It's going to come in useful in part 2, or in part B, sorry. But for now, this plus minus is going to give us two values, right? Those two values will be time values in seconds, right? And those values are 51.21 and 7.57. Those are our two values, and those are in seconds. Sorry, didn't write it. Those are in seconds. And that is the amount of time that, or the time after time 0 that these two will be at the same place. But if we look at what the question is asking, you're looking for the distance traveled by the toy car, right? So let's go back to this formula here. Let's rewrite it. Delta x equals vi t plus 1/2 a t squared, right? We're going to do this for the toy car. So if you remember, the vi for the toy car is 0. So this is 0. We can ignore that. We know the acceleration. That's the acceleration of the car, ac. And this time are these two values, right? So we plug in these two values. And what do we get? We get 216.39 and 4.73. So what this means is the first time that AV catches the toy car is after the toy car has moved 4.73. So we're going to write first equals 4.73 meters, right? That's how far the toy car has traveled the first time. The second time, right? Where did my mouse go? The second time, the toy car has traveled 216.39 meters, right? And there we go. That's our answer to part A. Put a circle around that. A. Boom. Done. Nice. Okay, moving on to part B. Let's look at the problem for part B. So, part B is we need to find the speed at which, the speed at which AV catches the toy car only once. So, let's think about this here. Most of the work is already done for us. If we go back to this quadratic formula here, this plus minus is the reason we have two answers. Because we can add this value, we can add this square root b squared minus 4ac, we can add it or we can subtract it. But if we make that equal to 0, then adding and subtracting 0 does the same thing. It both does nothing, right? So we need to find the value at which this b squared minus 4ac is equal to 0, right? And let's go back to what the question is asking. The question is asking of these new minimum constant speed. If you remember, that is our velocity for AV, aka our b. So our b is the unknown here, right? Now, we can still go back and plug in this negative 2va, but we do not know the value of 2va. That's what we're looking for now, right? So we know that. Also, one more thing before we go. before I move on, we know that square root of 0 is 0. 0 squared is 0, right? So we can ignore this big square root here and just make this b squared minus 4ac. We can just make that equal to 0, right? Because the square root of 0 is 0. So we have to make this part inside equal to 0. So let's rewrite that. B squared minus 4ac equals 0. Now let's rewrite this with our values up here for the variables that we found. So we know our b squared is going to be negative 2 VA, that would be squared, minus 4 times AC times 64. We want that to be equal to 0. In order for something to be 0, using subtraction, the first thing has to equal the second thing, right? 5 minus 5 is 0, so let's set them equal to each other. So, so negative 2 VA squared equals 4 AC times 64. And since this number here is being squared, we can just ignore this negative, right? So 2 VA squared equals 4 AC times 64. Now we can find what 4 AC times 64 is, right? If we put that into a calculator, 4 times 0.165 times 64, it equals 42.24, right? 42.24. Now that's equal to 2 VA squared. If we take the square root of both sides, we can do that. Square root of both sides, we get 2 VA is equal to 6.5. Divide both sides by 2. We know that our new VA is equal to 3.25 meters per second. That is the minimum speed at which Avi needs to run in order to only catch the toy car once. Okay, that is it. Thank you very much.